before we start.
Extra chairs, anybody? No?
Thank you so much. Thank you all for coming here. I didn't expect so many people to show up. It means a lot. And thank you, Ms. Alex, for the amazing introduction. Ms. Alex gave a quick description of the project itself, and I'll probably show a demo in a few seconds. But before I even begin, I want to thank firstly Ms. Alex for helping me so much with sharing it with so many people.
Keep going, thank you.
And also sharing with so many people, motivating me to work on this, and also getting so many people here to look at such projects. And she's always encouraging people to work on such stuff. From the first day this year when I started our programming club, and as well as BCYDC, which is an organization for high school developers in BC. Ms. Alex has always pushed forward and encouraged us to do as much as we can. And it's really been really helpful. So thank you, Ms. Alex. I'd also like to thank Ms. Smith, who's right here. Ms. Smith has been our ASL teacher at South for I don't know how long, but 10 years. But yeah, I've been in Ms. Smith's ASL class since grade 9, and it's been an amazing experience. And as most of you know, we work with BCSD, Burnaby South is also part of BCSD. And our ASL class has taught me a lot, not only ASL, but also about deaf culture and the language itself. And I might not be the best ASL learner itself, but I think the culture and the cultural aspect that Ms. Smith teaches us has been enlightening, and it's opened so many, my eyes to so many things that happen at our school that we normally wouldn't notice. So, and also over the last few months, I've been showing Ms. Smith this project, and she's given me a lot of advice and guidance towards working on this project. And that's made it a lot better and a lot more inclusive as well. Because before this, it was just me assuming what would be helpful and what would work. And talking to Ms. Smith to get insight about the project itself has made it a lot better, and also given me a lot of insight on what to work on. Besides that, thank you, Dr. Hall, for coming all the way from UBC. It's been amazing, and all of you for showing up. It's been amazing seeing all of you. And a lot of you have seen me work on this project over the last few months, and also helped a lot as well. So thank you so much for showing up. I'll give you a quick demo. I have a demo video from earlier. So if you don't already know, basically the project is an ASL translation tool. So it has both receptive and expressive aspects. So one, as a deaf person can sign. A deaf person can fingerspell, and the tool basically transcribes the fingerspelling into actual sentences. Or two, a hearing person can speak, and a 2D avatar basically signs all the words that the person says. So I have a quick demo video I took a few days ago. I'm not sure if the audio works. So on the right, it's the 2D avatar that basically signs things. And on the left is basically the receptive part of the project. So as I fingerspell, you'll see it transcribe. And when I speak, you'll see it sign. So I'll just play it right here. You can't hear the speech, but actually. I'm a junior at Burnaby South Secondary School. So this is still a proof of concept, but the main thing is that I can fingerspell, and fingerspelling is basically spelling out words using alphabets, essentially. It counts for about 20 to 30% of expressive ASL. So basically, if you see here, when I fingerspell "who are you," so basically this is WH, and these are the individual alphabets. And then it basically transcribes into text. And then there's always going to be inaccuracies and typos, so you'll see it automatically fixed. So at the start, it was a double W, and that fixes to be an actual sentence. And then for the text part, it basically starts out in English, exactly what I say, and then it rearranges the words to be ASL grammar. So for example, ASL actually goes object, subject, verb. So for example, in English, I say, I ate an apple. When in ASL, you would go, apple, me, eat. So basically, you rearrange the words to be a different grammar structure, and that's what happens here. So when you see it sign, like when I say, I'm a junior in Burnaby South. I'm a junior in Burnaby South Secondary School. So it basically glosses into ASL grammar. I think I can get a live demo working as well. I can do that after. But I'll just give a quick rundown. We have a lot of people here. We have both CS students and ASL students. So I'll try to keep it intertwined. So I won't go too in depth, but if you have any questions, just let me know. So right here, I have a document that basically documents every single thing about the project. So I'll start out by talking about ASL itself. I'm definitely not the most qualified person for this, but I'll just give a quick introduction to the language based on my own knowledge. Feel free to butt in if you have anything useful to say. So on the left here, this is what a normal conversation looks like. There's one person speaking, one person receiving, the other person speaking, and the other person receiving. And it's just a normal conversation as most of you are used to. But in the moment you have a language barrier, so like two different languages, or even ASL to English, you always have a tool in between, which basically serves to translate between the languages. So this can be something like a human interpreter, or it can also be like Google Translate or a similar tool. Now the problem is that ASL is a visual language, and visual languages are harder for actual technology to convert between. And so that's the main issue, or the main lack of technology that we currently see in ASL. So there are tools that, the most common approach from what I've seen is that most people actually type it out, like type out things they're saying, and then they pass a phone around, they pass a pen and paper around. And the main goal has been to basically, while human interpreters are obviously amazing, the main goal has been to have a no-cost technological tool that can translate between ASL and English. And so, as I said earlier, the moment you have like a text pad or a keyboard conversation, there's a lot of additional hoops for the deaf person. So for the hearing person, it's basically the same. They just speak and they listen. For the deaf person, they need to convert from written English to ASL gloss to ASL signs, and then the deaf person can basically process the ASL signs. And then when they express, they got to convert the ASL signs in their head back to ASL gloss to written English, and then they can speak out, they can type out the English. And this obviously, while for the hearing person, it's essentially the same. The deaf person has a lot of accommodations that they need to make. And that's what we've been trying to basically remove in the conversation process. The main problem with existing tools is that they've built in this misconception that ASL is the same as English, when this is not actually true. ASL has its own vocabulary, it has its own grammar, it has its own syntax. And so when you just write English, it's not actually ASL. A deaf person can read that, and it's not necessarily they're not able to understand it necessarily. And that's what I've been trying to basically change. And so with what the current solution is, it basically takes 3 of them out. And so the only obstacle is basically the deaf person has to use ASL signs, and they need to convert that to ASL fingerspelling, which is actually spelling out the alphabets. And everything else is removed to some sufficient degree. And that's been the main goal here. On the right, I just have a demonstration of what English grammar to ASL is. So for example, if you say, what is your name? It would become you name what in ASL gloss. And there's also like facial expressions and other like attributes to ASL that go way beyond this project itself. But this has been the main goal of the project right now. I can quickly go into the technology. For the receptive part, this is the main flow. So as you saw, there's a client. The client basically takes in a video. It uses something called Google MediaPipe. And Google MediaPipe essentially converts a video of hands into points. So if you look down here, each hand has 21 points, and this is each essential joint of the hand. And so what I do is I use Google MediaPipe, which is a ready-made thing that can run on the browser. You can download it on your phone, and you can try it out. And then basically, if it sees any hand in the video frame, it converts it to points. And then what I did was I trained a PointNet model. A PointNet model is basically something, so basically you feed it a lot of data of like each alphabet, and then it eventually with enough data and enough training, it can recognize alphabets based on the points you feed it, right? So that's the ASL classification model. I'll go into it further after. But then once I get the letters, so basically the moment I show my hand, it can realize what letter it is, and then I parse these letters into actual sentences, which is what you saw earlier. And finally, this is fed into OpenAI, which is just something like ChatGPT. It's just an LLM, and this is used to basically fix typos in the sentence. So if there's like too many letters repeated, or if it's obviously not a word, then it just converts into an actual sentence. And this is finally outputted into the client itself. For the model, My first approach was actually to just download a bunch of data sets of ASL science. So I can show you an example of this. So this is an example of a data set. And it's just like many pictures of ASL science. I'm not sure if you can. Here, so this is the sign for free. And so this is all publicly accessible. Anyone here can download it. It's completely free, and that's the best part of it. And this is just how many there are for free. And this is actually only one out of the 3 data sets I use. And so my first approach was basically to train something called an image classification model. And so what it would do is basically you feed it a bunch of images and you label them. So if you feed in all these images and you tell the model it's basically free, and then you do it for every single alphabet. And then when you feed it images, it can classify into like one of the alphabets. And the problem, there's 3 main issues with this. One is that it's not real time, because dealing with images is really hard. They're a lot of data, and it's really hard to classify them. So it would always take maybe a second to classify these images into an actual alphabet. And even then, it's affected by a lot of factors. So for example, this image has a red background, and it's a person with a light skin tone, while a different image might have a different background, and the hand might be further away from the camera. So there's a lot of issues that you need to deal with. And that's where Google MediaPipe basically came in. It allows you, the moment you convert this into points, it's not really affected by the race, it's not affected by the background. If you normalize it, it's not affected by the distance from the camera, and it fixes a lot of issues. And it also makes it a lot faster, because you're only dealing with 21 points instead of a whole image. So that was actually the main approach towards this, the main solution to this approach, basically using these points instead of the actual hand. So what I did was I had about 200,000 images of ASL alphabets, and what I did was convert this into nets. So it looks something like this. So this is the sign for B, and you can see it's basically a palm out front with the thumb tucked in, and this is basically what all of these are, right? And you do this for every single alphabet. So this is the sign for X. Something that's easy to see is probably L. So this is L, and you can see the signs here. And these are just visual images of it, but it's not. I don't actually store them as images. You store them as basically just points. And then the moment you do that, you can train a model. You can train a PointNet model using just this. So you take the 200,000 ASL images, you convert them to points, and then you train the model on these points instead. And now it's a lot faster because you're only dealing with points. And so when I just show my hand, it'll basically be able to classify it into a letter. I won't go too in depth, although I already kind of did, but this is just an
There's 2
image
people
of,
here that understand your language.
No.
Oh, there's more than 2 people.
Class.
Oh, okay.
Come on.
I got it. I got it. I'm following. I'm
I'm
following.
doing my best.
this is the graph of the accuracy. So you can see the more you train it, the more data you feed it, the more accurate it gets. And there's a sudden spike here, which is a mistake I made, which I can fix over time. But basically, it sounds really complicated, but you just keep changing parameters, how much data you feed it, how fast you train it to learn, and then it becomes more accurate. And so here is a confusion matrix, and it's actually really cool, because what you see here is where the model actually gets confused. So for example, this is perfect. So on the y-axis, we have the letters A to Z, and on the x-axis, we have the letters A to Z. And this is the actual value, so the value I signed. And on the x-axis, it's the value that the model thinks I signed. And if you look here, this diagonal line is perfect. That's how it's supposed to be. But this one outlier here. And this is basically, when I sign K, the model thinks it's V, right? And this is the sign for K, and this is the sign for V. And so it's really similar, right? So this is mostly where the model actually makes mistakes. It's when the signs are really similar. And so you see one spot here, there's one spot here as well, which is K to I, because they both have like a finger up. It's not that similar, but it still happens a lot. And there's many of these issues basically, like U and R. So that's the most common inaccuracy right now. I'll talk about how I fixed it, at least improved it later, but this is the main issue. And honestly, it's possible to be fixed with more data, more training and stuff, but it's still something that's always really confusing for a computer to basically solve. That's mostly the receptor part. The main fix finally is to feed the data into an LLM. An LLM like ChatGPT, any language model, basically can identify issues in the sentences and they can fix it. And I'll demo this after. The second part is the expressive part. And I won't bore you too much, but basically what I did was I downloaded, like, if you search up a word like hello in ASL, there'll be a website that has someone with a video that signs the word hello. And what I did was basically download 9,500 videos for different words. And then I used Google MediaPipe again to basically convert the videos into points. Right? And then I store these points in a database. And then I store this word in the database as well. And so this is actually really straightforward. When I say, hello, my name is Kevin, it goes to the database and it gets the sign for hello, it gets the sign for my name is Kevin, and then it displays the signs exactly as they are, right? And there's a few main things that I had to take care of. One is rearranging to ASL clause, and this can just be done with an LLM again. So you can either use OpenAI's API, which is really cheap, or you can just run it on your computer, which is just like Llama 2, Llama 3, etc. And the second thing is using embeddings. So basically, since the ASL dataset that I had of all the videos was only about 9,500 words, right? And English has about 150,000 words, so there's obviously a big gap. And so what you do is you use something called an embedding, which basically allows you to find similar meaning words. So if I say hello, say I have the word hello in the database, but the person says hi, right? And say the word hi is not in the database, then I just use the sign for hello. And I can explain how it works later as well, if you want to know. But that's basically how it works. And just using embeddings basically expanded it from 9,500 words to like tens of thousands of words, because you can use contextually similar words. For future work, there's a few limitations I'll show you after. One is that it's only finger spelling. Finger spelling is about 20 to 30% of Express ASL. And so obviously a better version of the project would have actual ASL words as well. And this has more complexities, which I'll talk about in the future. Two, it can be made more accurate. This is with more data, more training epochs and stuff, and that will definitely improve it. And finally, there's 5 main parameters of ASL. So if you look here, so ASL has movement, location, orientation, non-manual signals, and hand shapes. And the model definitely doesn't think about them as individual parameters, but to some extent it has movement, location, orientation, and hand shape. I mean the expressive part, like it can move its hands around. The main thing is that it does not have non-manual signals, which is basically facial expressions, like head nods, like raising your eyebrows, stuff like that. And one way that could be tackled is to, instead of having a 2D avatar, is to actually have like a person, like a 3D model of a person, and you can move their face and stuff. But that's definitely things that can happen in the future. And one of the more niche use cases that I was thinking of, I'll just demo it here. So for future work, it's basically, for actual words, there's something called RNNs and LSTMs. And these are basically AI models that take data and remember the data. So it's called, LSTMs are basically long short-term memory models, and they basically have a memory. And so if you have words are basically moving animations. So it's a lot harder than finger spelling, which is basically just a single sign. Words have a moving animation. So using an LSTM might be one approach towards basically tackling the issue of animations. Furthermore, 3D model is what I talked about for facial expressions. And also, one thing, there's 2 main things I could think of. One is having just a Chrome extension that basically adds a YouTube caption option to YouTube videos. And so when you're watching a YouTube video, you can enable YouTube captions, and on the side, it's an ASL interpreter that just signs everything that's said in the YouTube video. Or 2, one could be a webcam client, which is basically like I'm making a video, and this, everything I say is basically repeated by an ASL interpreter below me. And this can be helpful for making YouTube videos, joining Zoom meetings, and all of this stuff can happen without the need of a human interpreter. And so there's a lot of places this can go. These are examples of actual like products that can be made with the software. And so there's definitely I definitely want to explore some of this in the future. So for example, I need to log in. 1 second. But I've been working on a video to demo the whole project. And I thought it would be cool to basically have an ASL interpreter that basically signs every single thing I say. And so it's still not perfect. Sometimes it goes really fast because I speak faster than the thing can sign. But I'll just demo this. So I don't think the audio is too good, but if you look here, like basically as I speak, I have the interpreter saying what I speak.
And so they will typically serve as text-to-speech or speech-to-text services. And this puts a lot of additional steps for the deaf person to accommodate, to be a part of the conversation. And the main purpose of this project is made to basically fix that. So just to quickly
So basically, as I speak, there's an interpreter signing everything I say. And it's not perfect, but hopefully it gets better over time. But this is the first iteration of what I have so far. But yeah, that's basically how the project works. I can do a quick demo. I'm not sure how much my computer can handle at once, but we'll try. Hi, my name is Kevin. So you'll also notice when you have a proper noun like Kevin, it's not going to have a sign for it. So it basically finger spells what you say using each alphabet. The voice recognition is not the best because I'm using it on device. So it can be improved by using an actual AI transcriber. But basically everything I say, it just repeats. And there's also obviously a receptive aspect to it. So this is it, finger spelling everything. I turned it off. I'll just fix that. Or connected to my phone. Oops. Sorry, give me a second.
So Kevin, do you think, how do you think you might take what you have here and bridge it into it receiving somebody's sign language, not just their finger spelling? Like what would you need to have, what data would you need to have? How do you think you might train your AI and code it to accommodate that? What pathway do you need?
So one big thing is that for the ASL, for the finger spelling aspect, I have 200,000 images of ASL alphabets. And so for each alphabet, I have like at least 10 to 15,000 images. And the problem is that for this to work on words, it would basically need that many videos of these words to be at least sufficiently accurate. And so that's a big obstacle because there's no actual database of that many words. So for example, for the expressive part of this, I just have one video for each word. But for it to receive ASL, it needs to have multiple videos of each word so that it can actually receive ASL. And so that's one big obstacle. The second obstacle is that obviously it needs to deal with videos instead of just pictures, which is a big aspect. But there's already technology that works for this. So it's definitely going to come. And actually, recently I stumbled upon this project, which was ASL Lex, which is essentially a database of basically every ASL sign. And it has data about each sign. So for example, if I go here and I pick any ASL sign, so this is a sign for slides, and it has data about it, like where the location is,
Oh.
the hand shape, and stuff like that. And I think using a model that basically identifies, like, say the sign is here, it can narrow it down to the signs that take place in this location. And then it makes it a lot easier to actually decide what sign it actually is. And you can use context of the sentence to basically analyze what sign it is. And so, so you can see the sign for desert is this. And it's really close to the sign for try.
I would add to that, it's like a machine learning, and as everything in machine learning, the more amount of data you have, the more precise and faster it is. So, in my opinion, it's a team's job, and this is where what we were talking with Kevin, we need to reach out to get team. It's more data, and more data.
Yeah.
Preciseness goes really.
I was getting along the line and picking your brain at what you just said about what we would probably categorize it by location and then narrow it down from there, because you have the points that you're going to be able to do if you do that, but you're also going to need to think about those other things. So I like that answer.
Yeah, so narrowing it down to location will make it a lot more effective and accurate.
And this whole has, sorry for the interruption, they have also a presentation which they will tell us what. Guessing it's very similarities there, so it's more to come.
I believe Dr. Hall actually has something similar to this for assignment.
It's related, but not quite the same, but I'm happy to talk about the.
Yeah, so Dr. Hall has similar concepts as well. But yeah, that's basically how this project works. I was getting a demo working earlier. If you have any questions, just let me know.
It's working.
Yeah. So I can go.
Do you need better lighting? Sometimes when
It's pretty good. So you can see it made some mistakes. So for example, A and M, A, M, N, S, T are all really similar signs. And it's really hard for the computer to basically differentiate between them. And so it basically uses an LLM to fix the typos as it goes on. And there's also a lot of, the thing is the AI is only making estimations based on what it sees. And it's basically predicting things with some confidence. But it's always going to get confused between A, M, N, and similar letters. And the thing is, this can be tackled. I'll just turn off the interpreter for now. This can be tackled by basically just normal if statements. So say this is the sign for A, and this is the sign for T, right? And you can just use an if statement to check if the thumb is in between the index and the middle or not. And so while the AI is really, really smart, and it helps differentiating between like L and S and really unique signs, to just differentiate between A, S, M, and similar letters, you can just use if statements to just compare what the letter actually is based on just a single finger position. And so I haven't done it to the full extent, but I'll just show some code here for the recognition.
That's a result of like 3 months work on the just.
So like I haven't done the S, M, N part, but if the letter is A or T, then I check where the thumb tip is, I should zoom in, sorry. So this is actually really simple code. Like the AI part looks really hard, but this, I think, I'll talk more about it after, but getting into it is a lot easier than it seems. I know Schlock has been working on getting into ML and AI recently as well, and I think all of you should at least look into it because it's something that's really, really cool. And it seems really hard, but there's a lot of resources online to get into it. But yeah, this is actually a simple part of the code, which is just a basic if statement. If the letter is A or T, then I check if the thumb, I find the location of the thumb tip, the middle part of the thumb, and the index tip. And then if it's a left hand or a right hand, I check the X position of the finger. And this helps me fix inaccuracies between A and T, because it used to always get A and T wrong. And so I want to expand this. I was actually doing this for the letters I and K. You would have seen when I signed K, it actually got I a few times. I'm trying to fix that as well. Same for D and I. This is the sign for D, and this is the sign for I, right? And the thing is, between the left and right hand, D on the right hand is basic conditionals like this will help fix issues like this. But yeah, that's mostly how the project works. I can go, if you have any questions, feel free to ask. Ms. Smith, has a lot of knowledge about ASL, and if you have any CS questions as well, I can talk about it. But yeah, let me know if you have any questions.
I would suggest that we see the presentation from Dr. Hall and the students Grace and Stanley. We can switch, and
Yeah.
then we can open for questions from anybody
Oh, yeah,
or
sure.
anything. It's like HDMI to. Yeah.
She got her bachelor's from the University of North Carolina, linguistics as well, before doing her master's and PhD at Ohio State University. She moved to UBC, I think, 10 years ago.
12, but yeah, pretty close.
Yeah, and she does a lot of research about linguistics and all spoken languages as well as visual languages. And yeah, I'll hand it over to her to speak.